you guys, Joey, can you hear me? Oh, good. Okay. All right. I'm going to go ahead and get started. My name is Jared Atkinson. I'm going to be talking about flipping the script, Microsoft's post-exploitation language. Oh, wait. Oh, shit, wrong button. Okay. Oh, no, we're actually talking about Microsoft's incident response language, and my pop-up's coming up from network. Okay, so what I'm going to be talking about is defensive PowerShell, kind of concepts around that, different security models that people have used over time and how that's kind of evolved, threat hunting and what that is in general, and then I'm going to go through kind of my threat hunting methodology and how I implement PowerShell into that, right? So how do I integrate PowerShell into my threat hunting methodology? Some of the tools that I use for that, and I'm going to demo some of them. So a couple of these you may have heard Will reference this morning. I'm going to go into a little bit more detail and kind of show some different demos. Who here was here last year? And who saw like my terrible AV issues on the first day? Okay, yeah, so I literally, I couldn't get HDMI to work on my MacBook Pro, so hence I have a new computer. And so my demo on the first day, I literally made up as I went. And so I actually implemented the demo that I planned to give last year into this presentation. So you're in luck. Yep. All right. So we kind of PowerShell from the security community's perspective has kind of gotten a black eye over time. So we see things like PowerShell Empire, right? So these two people right here are the reason for a lot of this, right? So PowerShell Empire is a PowerShell-based remote access tool. PowerSploit, we have Microsoft's post-exploitation language, so that's kind of what I was referring to from Chris Campbell in the beginning. OJ, he does Meterpreter for the Metasploit project, he's done some stuff with PowerShell. And so a lot of security folks are starting to kind of be very negative towards PowerShell, right? And Phineas Fisher, who did the hacking team hack, right? He hacked hacking team and released all their tools. He said the best tool for understanding networks is PowerView, right? Which is another PowerShell tool that Will wrote. So then there's all this, consternation about whether or not we should disable PowerShell. Yeah, some of these are serious and some of them are not. So even like Swift on security. Who here is familiar with Swift on security? Everybody follows her, right? She's basically asking, hey, what should we do about this PowerShell thing? And this guy's saying, hey, PowerShell's disabled domain wide, right? And so it's kind of like the way that we're trying to, or some folks are trying to address PowerShell security is they just disable PowerShell throughout their entire domain, or disable PowerShell, right? And so where there's a will, there's a way, right? And so Will's talked about it with unmanaged PowerShell. So a coworker of ours created a tool set called unmanaged PowerShell, which allows you to load up the .NET Common Language runtime into a C++ processes memory space, and then run PowerShell from there. So he demonstrated PS inject this morning, which does that, right? Or you have, for instance, Ben 10 wrote a tool called not PowerShell, which is just a C# application that implements the system.management.automation DLL, all the classes that PowerShell would need in the run spaces and things like that to be able to run PowerShell without PowerShell. PS attack is another attack framework that does a similar thing. So at the end of the day, blacklisting PowerShell.exe really isn't going to do anything from a security perspective because the attackers are basically making their methodology work around this from the beginning, right? And so they have methodologies that completely bypass the need of PowerShell.exe. And so rather than try to disable PowerShell, why don't we as defenders or people that are concerned about security embrace PowerShell, right? And so to kind of frame the concept of what I'm going to be talking about, I want to kind of go into this cyber kill chain. And so this is a lot of people have heard like the hacker methodology. Lockheed Martin released a cyber kill chain, which is basically all the steps that an attacker needs to take in order to achieve their objectives. So regardless of what an attacker wants to do, they're going to need to do some semblance of these steps in order to achieve that objective, whether that's still PII from a SQL server, whether that's get domain admin and then still some plans for the next jet fighter or whatever it is. They need to go through a discovery phase, discover what's going on in that environment. They have to deliver some sort of payload. There has to be an exploitation that takes place. They need to have some sort of C2 so that they can provide command and control to their implant. They need to escalate privileges so that they can gain access to what they need access to. They're going to have to laterally move. So typically when you gain access to a network, you're not on the system that you need to be on to achieve your objectives. And then you need to do some sort of data collection and data exfiltration, get that data out of the network and onto your own system. All right, so back in the day, we kind of started off with this concept of defense in depth, right? And so while this is not trying to, I guess, kind of shit on defense in depth, it's a necessary thing. It's not an end-all, be-all, right? It's not meant to be the only security you need to put in place. So things like firewalls and intrusion detection and prevention systems, antivirus, web proxies, all of these things, originally we thought, hey, if we just make this really gigantic boundary around our network, nobody's ever going to get in. And while we don't want to get rid of these things, all it takes is one user to get an email and double-click on it and open up, a Word document with a macro, and now the entire network's down, right? Or they own the entire network. And so ultimately, what defense in depth is going to be targeting is the discovery, delivery, and exploitation phase. So we're trying to stop them from the initial access. I would say that if that's your only security mechanism, you're probably not in a good place, right? And so ultimately, that kind of leads to this, right? So incident response, right? You ended up getting owned. You found it probably 300 days after it happened, which is like the average time to identification of an incident is around 260 days, according to Verizon, who does an annual report on these types of things. So attackers are in your network for 260 days before anybody even knows that it's happening, right? Which there's a lot of things you could do in 260 days. Incident response focuses on trying to clean up and also discover what happened during an incident, right? And so by this time, you're probably too late after 260 days. And so what are we doing? We're kind of answering this data exfiltration piece. What was the extent of the breach? What data was taken? That kind of thing. So ultimately, with defense in depth, we're answering the first 3 phases. With incident response, we're answering the last phase. There's probably something missing in this area that we're not really answering or looking at. And so that would be the post-exploitation phase, or the thing that somebody like Will specializes in. We basically assume that there's an adversary in your network. And so what we want to do is look for evidence of these things happening: C2 installation, post-exploitation, or privilege escalation, lateral movement, and data collection. And that's where a concept called threat hunting comes up. So threat hunting was started kind of in the Department of Defense in the U.S. So like the military, the U.S. government, other national governments are probably have a little bit higher need, or anti-type intelligence operations, and so they have a bigger need for being very proactive with how they defend their networks. And so ultimately, the idea is assume breach, somebody's going to get into your network, you need to be able to find them before they could steal the information that they're after, right? And so the idea is to be very proactive, look for evidence of these attackers' techniques, and so we'll talk about how we would start doing that. So I work for a company called Spectre Ops. We've kind of developed this technique, or this little flow chart for how we would do threat hunting. The idea is first discovery. So you have no idea how many times as a consultant I go into an environment and say, hey, how many computers do you guys have on your network? And they say, oh, we have 2,000. And you're like, okay, 2,000, that's great. Let me look at Active Directory. Oh, you have 16,000 computer objects in Active Directory. Something is off here, right? But when let's say I look at DNS records and DHCP leases, there's only 10,000. So where is the ground truth? And so discovery is trying to answer kind of that problem. Then we get into this kind of cycle here where we're gathering information, analyzing that information, and then doing an investigation on any anomalies or any type of indicators that we find during the analysis. And so we kind of go through this until we find something that is malicious, and then we go into a response phase. And so I'm going to be focusing on this talk in kind of the gather, analyze, and investigate portion. So now we could get to kind of PowerShell-y type stuff. So gather really kind of focuses on gathering information from endpoints, right? And so things that are really nice are things like auto-start entry points, so any type of persistent mechanisms. So things like registry run keys, startup commands, WMI event subscriptions, all those types of things, or any evidence of code injection. So at the end of the day, if a bad guy wants to be in your network for 260 days, he's going to need to have some sort of persistence to keep him there for long periods of time. You're going to hopefully reboot your system within 260 days, and so he wants to be there when it comes back up, right? Other things we could look at are like processes, services, network connections, registry, different files that are on the file system, that type of thing. All right, so there are 2 protocols that end up being really useful for gathering this information. One is WMI, which has been basically always available since Windows 95. It's almost always available. Sometimes there's some corruption issues with using WMI. And then the data, but the problem is the data is limited to WMI classes that are on that operating system. So WMI is better on Windows 8 as far as the amount of information you could gather than it is on Windows 7 or Windows XP, because there's new WMI providers on newer operating system versions. So similar to what, if you were here for Alexander's talk last session, he talked about how like Server Management Tools has new WMI providers that they made available that you can kind of use yourself. And so, so Windows 10 is going to allow more data gathering via WMI because of that. Another option is WinRM, right? So WinRM is, you could use that on Windows XP, and it gives you literally the access to anything that you want to do in PowerShell from a coding perspective, available on a remote system. So that means things like accessing the Windows API, accessing commandlets, accessing .NET. And so using WinRM kind of opens up our ability to use or gather different types of information. All right, so when we're using, I talked about WMI and WinRM. Ultimately, when we're gathering information, there's kind of two perspectives, right? So there's a pull methodology, which means I'm going to reach out to every one of you and say, hey, tell me your processes, tell me your processes, tell me your processes. I'm going to gather all that information back, and I'm going to put it in some backend like Splunk or Elk or something like that. The other option is push, which is where I'm going to let everybody know. I'm going to say, hey, every time you have a process that comes up, I want you to tell me about it. Every time you have a process that starts, I want you to tell me about it. And that way I just kind of sit there and passively gather information. There's pros and cons to both of those. As a consultant, I usually end up kind of doing this pull thing because it's really difficult to go into an environment for 3 weeks and say, hey, you guys need to install, this agent or, Carbon Black or Uproot or Sysmon. They're just going to say, yeah, that's never going to happen in 3 weeks. That won't happen in a year, right? And so we end up falling back to kind of this pull methodology. Some of the cons of the pull methodology is that it's usually relatively slow compared to the push, and you're going to miss information between pulls. So if a process starts and stops between a pull, so let's say I'm asking you for your processes every 30 minutes, and if you have 10,000 computers, that's relatively reasonable. If a process starts and stops between 30 minutes, I'm not going to have any information on it. And so you kind of are doing a battle there. So this actually is very relevant compared to the last session. So somebody was asking or talked about how security is very negative on WinRM at their job, right? And so I've run into that quite a bit myself. I was in the Air Force in the U.S. for 5 years, and they were very negative on WinRM. But they want to have things like SMB, right? SMB probably has the most prolific exploits ever known to man that were targeting it. So like MS-08067, which Windows XP got completely owned by Conficker back in 08. And then if you're looking at the news recently, Shadow Brokers released another SMB exploit called Eternal Blue just a couple days ago. And then RDP, we all love RDP. It gives us a GUI. It makes us feel comfortable. But at the end of the day, it's creating an interactive logon, which means that your admin credentials that you're using to do that logon can now be stolen by an attacker. So if you're familiar with Mimikatz, RDP makes you vulnerable to Mimikatz stealing your password. Other things that are really cool is WinRM gives you the ability to do PowerShell remoting and Windows Event Forwarding. So PowerShell remoting for polling data, and then Windows Event Forwarding for pushing data to a centralized location. The other really cool thing is it is encrypted by default, right? And so a lot of times you have people have consternation over whether to use HTTP or HTTPS in association with WinRM. At the end of the day, in a domain environment, HTTP is perfectly fine because it's going to be encrypted by default. And so what SSL is really giving you is giving you two-way trust, basically. So you're doing like two-way authentication and checking the certificate to make sure that nobody's man-in-the-middling your connection. Yeah. That's correct. Yeah. So there's a lot of like nuance to this whole concept, but in general, network logons do not expose your credentials on the remote system as to where interactive logons do. So interactive logons would be logging onto the console, RDP, Task scheduler would be network logon. I'm almost positive, not 100%. Things that are network logons are WMI, WinRM, probably task scheduler, I would imagine. I'd have to check that. But the WMI and WinRM are not going to expose your credentials on the remote system. The exception is like CredSSP. CredSSP is going to expose your credentials if you use that because that allows you to do that double hop. So generally, when you have a double hop issue, if anybody's familiar with that, that means that your credentials were not passed to the remote system and therefore are not exposed on that system. And in this case, we're looking for bad guys, and so generally we don't want to be spraying our credentials all over the place, right? All right. So we've developed a few, just kind of the defensive PowerShell community has developed a few tools to kind of answer the mail on the gather phase. And so one is SimSweep, which is a Matt Graber wrote it, and basically it's a SIM-based data gathering project, I guess. So the idea is that you can use DCOM or WSMan to gather information like as simple as a process listing or as kind of specific as overarching auto runs in the registry, right? So you could say get sim registry auto runs, and that's going to return a list of all the known locations where persistence can be had inside the registry. And so if you've ever used auto runs from sysinternals, it's very similar to that. I don't know if it has like for like parity yet. Yeah. 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 So he's made it very similar to auto runs to where if there's a tab in auto runs that says this is a type of persistence in the registry, there's a switch in that commandlet to allow you to look for that type of persistence. Another cool thing about SIM is you can establish SIM sessions. And so one of the most time-consuming parts of using WMI or the pull methodology is establishing or authenticating with the remote system. And if you're doing that 10,000 times, that adds up. And then you have timeouts and all kinds of bad things. And so in this case, you could establish SIM sessions, authenticate once, and then kind of run multiple commands. And so it makes it a little bit faster. Another project that's just kind of starting up. So Lee Holmes is kind of one of the brainchilds behind this, and then a guy named Carlos Perez, who goes by Dark Operator, is kind of leading it as well. But it's called PS Gumshoe. I don't know where the name came from, but the idea is to develop commandlets that are kind of standalone and allow you to gather information that would be relevant to an investigation or like a hunting exercise. And so we have some analytical scripts, so like a script that implements the Damerau-Levenstein algorithm. So the idea that it's kind of like fuzzy matching. So you say svchost.exe, that's a commonly used name of malware, or maybe scv or scvhost.exe, right? So they switch one letter. Well, this algorithm allows you to basically say, how similar are these two strings? And so svchost and scv, I don't know, you guys know what I mean, right? So svc and scv, those only have one character difference, and so that algorithm's going to tell you that, and so you can say, show me anything that looks similar to LSASS or svchost or SMSS or CSRSS, that type of thing. We also have different artifacts like name pipes, so we could gather name pipes, you could gather handles, that type of thing. And then attacker techniques, so like invoke or get injected thread, which Will showed, and I'm about to demo here in a second. And then the cool thing is it's transport agnostic, so we're providing the script, you provide the transport mechanism, probably WinRM, maybe some kind of cobbled together web server or something like that. It's also backwards compatible. I wanted to throw in kind of a call to action. When I say backwards compatible, I mean everything needs to run on PowerShell version 2. So there's a reason for this. So in the offensive and defensive kind of community, we go in and we don't necessarily have control over the environment. So it's a little bit different from, I guess, a system administrator perspective. And so if we were to limit all of our tools to the latest and greatest PowerShell version, then we'd be completely screwed, because I've never been to an environment that was fully Windows 10. And so you show up and you need to be able to run on maybe Windows XP, but definitely Windows 7. And so that's going to be PowerShell version 2. And so you need to be compatible with that. Call to action, if you are interested, if you're interested at all in kind of contributing to this module, please reach out to me or Carlos Perez or Lee Holmes, and we'll definitely kind of give you some things that we've thought about and maybe get some help from that. So here's the GitHub repo if you're interested in checking that out. All right, so get injected thread. real quick, just kind of want to talk about it. So it's built on PS inject or PS reflect, not PS inject. It detects PS inject. PS reflect allows you to use reflection to call Windows APIs through PowerShell. The way that it works is it basically kind of a little run through. So Windows has a tool help API which allows you to say, I want to see every thread on the system, right? So you gather all the threads and then you kind of start to iterate through them. As you're iterating through them, you check their base address and then you check the information or the memory page information about that base address. When you get there, you're going to check to see if that memory page is committed, meaning that it is allocated currently, and whether or not it is backed by a mem image, meaning a file on disk. And so if a thread's base address, if the thread's base address's memory page is allocated and not backed by a file on disk, then it is some sort of code injection. And so then we would return the details of that offending process. So we'll do a quick demo. So this is PowerShell Empire, and Will help me film this. Hopefully it works. All right, so what he's doing now is he's going to kind of do like a lazy way to get a beacon back or a call back from Empire. So he's going to infect this Windows 7 system. And this is just for kind of making the demo a little faster, but he just ran basically a stager to get the callback. Now he has a callback from that system, and he's interacting with it. He's doing a process listing. What he wants to do is he wants to get out of PowerShell. So a PowerShell running with that encoded command is like a huge flag. And so he wants to migrate into the LSAS process. And so he's going to use PS inject, which allows him to inject his Empire rat into the LSAS process. So he's going to execute that. And it comes back here in a second. All right, there we got it. And so now he has two agents. One is in PowerShell, as you see, and one is in LSAS. So he's going to go ahead and get rid of the PowerShell one. He doesn't want to like flag a defender and see, hey, there's a PowerShell running with this long encoded command. Now he's just inside of LSAS, and there's nothing different about that LSAS from a defender's perspective, right? So he ran kind of a PowerShell listing. PowerShell doesn't exist on the system anymore. And so now he's going to look at all the processes just to kind of show that the agent is getting responses from the remote system. So what we're going to do is we're going to use get injected thread, which immediately returns and tells us, hey, there's a thread injected in LSAS. Here's the information about it. You see the thread ID, which is quite important. You also see that the memory page is marked as read, write, execute, which is typically not a good thing. There's some situations like just-in-time compilation that's okay. You see that it's committed, and then you see that the memory type is memory private, which means that there's no file backing it on disk. There's the base address and the size of the memory page, and then we also dump out the first 100 bytes of that memory page so that you could do some disassembly on it, or maybe do some reverse engineering. All right. So now what I'm going to do is use stop threads. So I can't kill LSAS. That's kind of important, right? So what I'm going to do instead is I'm just going to kill that single thread which is running Empire. And so now when we run get injected thread again, that thread's gone. And now Empire, the guy's coming back and he's like, hey, I want to get a process listing, and nothing comes back. So we were able to kill the Empire thread, and so LSAS is all happy. Now he's angry and he's like, what? Yeah. So we were able to kind of surgically remove him from the system. Let's see how. So that probably gets into a really deep conversation. Kind of depends on what they did with the Empire listener. Can we talk about that maybe afterwards? Otherwise, I'll definitely run out of time. All right, so that was a pull methodology, right? So get injected thread idea would be to run that through invoke command or something along those lines, and then you're getting that from remote systems. You may be able to run that. So for instance, anybody familiar with Tanium, the kind of configuration management tool? No? Oh, like 4? Okay. So Tanium is a commercial configuration management tool. What they do is they use get injected thread to run that across an entire enterprise, gather all that information back, and then say, all right, so this enterprise has semantic endpoint protection. That's going to flag because semantic does a lot of crazy stuff. But then it also has these onesie twosies that are doing kind of bad things, so we could look into those. But then from a push perspective, we have Uproot, which is a WMI event subscription-based intrusion detection system. So bad guys were using WMI event subscriptions to kind of get persistence. So every 30 minutes, if I don't have a callback going out to the Empire server, I want to run it again and reestablish my connection. But what we're doing is we're saying, hey, I want you to notify me every time a process starts. I want you to notify me every time the binary path of a module changes. I want you to notify me every time that system.management.automation.dll is loaded into a process that is not PowerShell or PowerShell ISE. You can do all these types of things. It's very flexible. I felt like I almost just kind of like went into a Trump thing. It's very flexible. It's the best ever. Lots of really smart people use it. Yeah. All right, thank you. Yeah. Man, that's bad. I watch too much news, I guess. So it reports events. So the cool thing is WMI event subscriptions have multiple ways that you can kind of gather that information. You can write them to a flat log. You could send yourself an email. The most practical ways, I think, are reporting to the event log. And so then you could use Windows Event Forwarding, which is available through or over WinRM. Or you could use an HTTP post method, which I wrote, and I'm going to demonstrate here in a second. So there's the GitHub project info if you're interested. All right, let's do this demo. I had a hard time with my demos last year, so they're all recorded now. All right, so first we're going to look at detecting lateral movement. So one of the most popular ways that attackers use lateral movement is through the Win32 process WMI class and its create method. So you create a process on a remote system. What I'm going to do here is basically create WMI event subscriptions are created based on a filter, which is what am I interested in finding, a consumer, what do I want to do with that once I found it, and then a binding which marries the filter and consumer together. So basically we're looking at this WMI provider exec method async underscore pre class for an object where it's Win32 process and the method name is create. And so that's our filter. What am I doing here? Okay, so I'm going to put that into the arguments there. And so now I've created the filter. So I have a filter that's looking for anytime somebody uses the Win32 process class's create method. Now I'm going to use the NT event log event consumer to basically write the information about that event out to the event log, right? So I'm kind of creating my own custom event log there, or event log entry. And so things like you could get the command line that was used with the Win32 process create method. All right. So now I have that. I'm going to marry those together with a filter to consumer binding. And then now I'm going to use invoke WMI method to just kick that off real quick and start up a command prompt. So imagine that I'm running this on a remote system and I'm kicking off an Empire stager like Will did in the previous example. All right, and so there's your malicious command prompt on your remote system. We go back and then check the event log here to see if it did in fact get caught and written to the event log. And here we go. We see that the Win32 process class's create method was called, and we have a command.exe was the command executed. So imagine that being PowerShell.exe dash encoded command, like blah, you know, that would probably get you pretty excited. All right, so the next thing that we want to do is I have this, there's an active script event consumer for WMI that allows you to run arbitrary Java or VB script every time an event occurs. So in this case, I want to have a listening post IP, which is configurable based on where you want this information to be sent to. And then I have this beautiful VB script. We're going to use the Microsoft XML HTTP COM object to then create, basically send a HTTP post out with the relevant information. So there we're going to put the listening post IP. Debugging VB code or VB script inside of a active script event consumer is a huge pain in the butt. Because like you have things like this. That is two double quotes right there. But ultimately what this code is doing is turning everything into JSON, right? So I want to convert my object into JSON and then send it out so that like you can send it straight to Splunk or Elk or any of those types of guys. All right. So I've just kind of like saved saved a lot of the configuration here in a file just so I don't have to type it out. But ultimately, this one's going to be kind of contrived, but ultimately we're looking for select star from Win32 process start trace. So Win32 process start trace is an extrinsic event type, which means every time a process starts, it's going to notify us about it immediately, right? And so we've established that filter, so we've said, hey, every time a process starts, tell me about it. Now that filter's actually been installed, or created, I guess. And now we're going to go ahead and create our consumer, yep. And so it's asking us our host name of our listening post. I'm putting localhost, and I want to go to port 8000. That could be basically anything you want. Here's the code. So active script event consumers allow you to have script text, and this is the script text that's going to be executed upon my my process starting. And now I'm going to marry those two things together with a event subscription or a filter to consumer binding. All right, there they are. All right. So over here I'm using PowerCat, which is just like a netcat type PowerShell script. I'm going to start listening on port 8000, and immediately a process started, cmd.exe. I think on this system I have, it's like my test system. I have some weird stuff going on in the background, so don't mind a cmd.exe just popping up in the background somewhere. But yeah, so it's telling you things like the time it was created, the source IP, the command that was run, the process ID, all that kind of stuff. So imagine that you're doing this on 10,000 systems all being filtered into a centralized logging application, and then you're able to do some sort of analytics on it. All right, so analyze, which is the kind of second step of that little triumvirate cycle that we're going through. At the end of the day, I love making PowerShell fit into the things that I want it to fit into, and there are some analytical steps you could take with PowerShell, but when you're gathering information from tens of thousands of systems, PowerShell is probably not the best tool. Personally, I like Splunk. Elk is a free, and I don't even know if it's open source, but it's free, definitely tool set to do that. And so you put all your information in there. I like to identify and sometimes exclude known goods. So maybe you have some sort of whitelist that you're bumping hashes against, and you're saying, hey, if this file is whitelisted, let's not even waste our time and put it in there. Reasons why this might not be good is there's a guy that we used to work with named Casey Smith, who's all about using signed Microsoft binaries to run bad code, right? And so run DLL32, MS build, all these types of things. We want to be a little careful. Then we want to identify and report known bad activity. So if something's known bad, it's on a blacklist. You reach out to VirusTotal and it says, hey, this is bad. Let's just go ahead and take the easy win and call that out. Then we like to work off of tactics, techniques, and procedures, TTP. And so one of the best places is MITRE, which is a defense contractor, came out with what they call the attack matrix. And so basically what they do is they take those phases that I had across the bottom earlier on, and they say, all right, lateral movement. Here are all the public ways that people can achieve lateral movement. Not specific enough to where this is the tool that does that, but here is the overarching tactic or technique that you can use to achieve that. And so we can start to look for evidence of those tactics being used. Another cool thing is least frequency of occurrence, which as you get more and more information starts to break down a little bit. But the idea, a lot of people call it stacking, which is where if we have one Win update service running out of 10,000 endpoints, it's only on one system out of 10,000, it's probably worth us spending some time to investigate and figure out what that is, right? That's kind of one of the easier analytics to do. First seen, if you've never seen anything and you've been monitoring something for months and you've never seen this process before, let's check out what that is. And then identify unknown unknowns that need further investigation. So things that maybe you don't know what they are, you don't know how to explain them. I like in analysis to avoid polarizing words like malicious, indicator, or finding, because people are going to freak out when you start talking about possible malicious activity, and usually you don't want that to happen. And then, so like words like item of interest and anomaly. And so the analyze phase, I never like to come out with a finding because you have this phase, right? The investigate phase. And so investigate phase is basically saying, at the end of the day, suspicious things come out of analysis, but you never really have enough information to tell whether it's malicious, right? Unless it's one of those known bad things. And so investigate allows us to kind of make the determination between benign and malicious, right? So you're taking something suspicious and determining whether it's benign, meaning not bad at all, or whether it's malicious, meaning definitely bad. And so we do things like data pivoting. So you could do like a forensic timeline, which I'll show here in a second. So maybe we have some sort of file that appears to be strange or malicious or suspicious or whatever. And so we can say, what time did that file arrive, or what time was it created on the file system? And so let's say it was created at 15:30 on September 1st, right? Now I can say, show me everything on the file system that occurred between 1500 and 1600 on September the 1st. And now I can start to build context around what's going on there. You could do this with network connections, running processes, persistence locations, file system activity, all kinds of things. So trying to build context around an event that occurred to try to understand what's really happening. Okay, so this is where I'm going to do that Power Forensics demo that failed last year. So Power Forensics is a PowerShell-based or C#/PowerShell-based forensic toolkit. It allows you to do things like build timelines based on file system artifacts. So right now it supports NTFS and FAT. Hopefully one day HFS Plus and EXT4. And if you're wondering why, maybe come to my talk on Friday where I talk about how open source PowerShell changed Power Forensics for me as far as trying to support Linux and Mac OS. And then it also parses the registry, program execution, so things like the prefetch, the shim cache, and user activity like different registry, like the user registry hive, and parsing what users opened and what files they accessed. All right, so this demo is based off of, for this demo I'm going to use a like forensic challenge where somebody infected a system and then asked a bunch of questions for people to answer. It was created for the Security for Arabs Digital Forensics Challenge by Binary Zone. And if you're interested in checking it out, that's the website. All right. All right. So there's lots of parts of this. So, all right. So first, I'm going to mount the image. So you could also do this on a live system, but this is kind of just a contrived. You could do it on a dead disk, a live disk. If anybody's into forensics, you can pretty much use it any way you want. The disk has been mounted as the G volume, so I'm going to be referring to the G volume using Jeffrey's old start demo from a while ago. First thing we're going to do is kind of look at the directory listing. And so if you notice, it was get forensic child item. So now I'm parsing the actual master file table to check things out. This is a web server case, so XAMPP is the directory that we might be interested in. So somebody intruded into a web server, forgot to mention that. And so now we're parsing the master file table on volume G. So next thing we're going to do is check out the master file table and look for anywhere where the full name is like XAMPP. And so the original master file table, we're going to compare, so we're kind of filtering down here. And so we want to see the master file table had 62,400 records in it. The XAMPP directory has 19,473 records. So we're already kind of like filtering down here. All right. And so now what we want to do is check out the different dates that files were introduced in the XAMPP. We see 17,605 of them were created on the 23rd of August. And then there were 2 other days that things were kind of happening there. So what we can kind of assume is that the 23rd of August was the day that the server was created, and then something weird was happening on the 2nd and the 3rd of September. All right, so we're just going to kind of add those dates to a group so we could reference them here in a second, and then kind of start investigating into them. All right, so we're going to look at that first group, which was the 2nd of September, and see what kind of happened there. And we're going to filter based on the file name modification time, which is the probably most accurate timestamp that we can deal with. And so you see all these session files. So on the web server, the session file means that you do a little Googling and you determine that the session file means that somebody tried to create a session with your web server. Then we check out the next day and we see one last session file, but then we see things like webshells.zip, phpshell.php, c99.php, phpshell2.php, and so we're starting to get a little interested, right? So somebody was doing some sort of brute forcing on that web server, and then they finally got access, and then they started uploading a bunch of files. It's kind of the initial triage that we're coming to. All right, so let's check out that the last session file. So it's going to have a little bit of information about what happened with the session. And so we see that somebody tried to log in with the username admin. And if we kind of went back, we would see that it was being brute forced with like SQL map and a couple other things. Obviously, this is not how fast forensics actually is in real life, but this is all real time. It's running real time. And so we see this is one of the web shells. We see an IP address that it's calling back to, or that it's maybe accepting information from. We see a port 4545. We could also read and figure out a little bit more what's going on there. And so this is where we like to do that temporal pivoting. So PowerShell is great because it has datetime access to like .NET datetime objects. And so we can start date of 9/3. And then we're going to add 1 day. So now we've created a temporal boundary from September 3rd to September 4th, and we can start kind of messing with things. So this is truly how fast the MFT parsing is in Power Forensics. So like I like to kind of talk about in case. In case parsing MFTs takes like tens of minutes, and this takes like tens of seconds. So take that in case. All right, so now we're going to build what I call like the window. And so we're going to say where the FN modified time is greater than start, and it's less than end. And so now we're limiting it based on kind of a temporal window. So again, we're going to compare the amount of MFT entries total versus the amount in our window. And so on that day we had, or there's 62,400, we had 22 files that were created on the 3rd of September. So now we're even more specific, right? We're kind of narrowing in our view to see what happened around that time. All right, so now I want to see what the names of those files were, what time they were created. And so here we start to see it's a lot of the similar stuff. We see that session. We see like a temporary internet file that's referencing the IP that was inside of one of the web shells. We start to see DVWA is damn vulnerable web application or something like that. PHP shell, web shell.zip. I don't know what this is, but you might want to check that out possibly. CD99.2.php, so on and so forth. You also see maybe a driver that you might want to throw over to your like reverse engineering shop. A driver being uploaded in your in some random directory on your web server is probably not necessarily a good thing. So the next thing we're going to look at is the USN journal, which is the update sequence number journal. It keeps track of all file system changes on your system. So the idea is for instance, like when you do backups and it does incremental backups, it checks the USN journal to see what files have changed since you last backed it up. Again, we're applying our window to this, and so USN journal, this is I think a little bit more drastic. USN journal has apparently 12,400 records. Within our time frame, there was 8,669 records. So there's a lot of file system activity during that time. And then what I like to do is group by file name, right? Then we kind of see how many times a file was, added, created, deleted, modified. We see that the server manager.log was 8,200 out of our like 9,000 different things that happen. And then we see things like tmpudvh.php. We see that's been deleted also. And then we see all of our PHP shells, php331.temp, and then PHP shell. We see that its record number in the master file table is 6230. And then we see that it was renamed to phpshell.php. And so just the type of power that we can use from the USN journal for figuring out what's happening on our system. All right. And then we could start doing git forensic content, so we could like recover deleted files. And so like what if we wanted to see what that PHP shell that was deleted was? Well, here we're seeing that it's basically taking a command and then executing it. That's what it looks like. So presuming that a MFT record hasn't been reused, we can recover a file. Here we're going to look at the Apache access log. So Power Forensics is a library that exposes a bunch of classes with methods and properties. And so in this case, this doesn't have a commandlet associated with it, but it's an exposed library or exposed class. We now can see parse out the Apache log, right? And so things like what the user agent is, the request that was made, the method, the timestamp, all that kind of stuff. So let's group objects based on the HTTP method, right? So if you're uploading things to a web server, a lot of times you'll be using posts instead of gets. And so we can look at those 70 posts instead of just like looking through this mountain of information. And we can start to see what type of requests were made to the web server. I didn't do it, but we also could have filtered around the time as well and kind of made that temporal as well, but I forgot. So here we see the user agent is Iceweasel, which if anybody's familiar with Kali Linux, Iceweasel is the default browser. We see some stuff being uploaded, maybe a command being executed here on the c99.php shell. So kind of neat stuff that you're starting to get into. And you also see that the remote host name is that same IP that was inside of that first PHP shell that we looked at. All right, so this is just looking at the requests kind of one by one without all the other information, so we could kind of easily scroll through it. So yeah, maybe there's XSS_S. I don't know. We might want to look into that. So at the end of the day, it's great that we could do all of this in PowerShell, but PowerShell may not, like I said, be the best analytical interface. And so a simple way to do this would be to make a forensic timeline to where we can start to build out maybe like an Excel spreadsheet of all the activity that happened, and we can start to make annotations and all that kind of stuff. And so here I'm getting a record. This is a master file table record. We have all these timestamps. We have the file name, that kind of thing. And so what you'll notice is that there's two different timestamps. So there's one on 9.3 and one on 6.9. And so I have a forensic timeline class that basically takes numerous different types of objects and then breaks them up based on the timestamp. So now we have individual objects for every timestamp that's represented. And so we know, for instance, this file was modified and changed at 7/20/45 on the 3rd. It was accessed and born on 6/9/2012 at 9:57. And so there's a few nuances about timestamps and how they get changed when you upload them or you copy them and all that kind of stuff that we want to consider. And so now we have get forensic timeline, which is a commandlet that allows us to do a timeline across multiple different types of information. So we have the MFT, the USN journal, the registry, the Windows event log. We're compiling that all into one kind of timeline, and shell link files, all kinds of stuff. And so now we can start to build a comprehensive timeline of activity that happened on that system. All right. Now we're going to kind of whittle it down because we have maybe 100,000 different objects or so, or maybe 200,000 objects. So we want to whittle it down to things that are relevant to our case. And 200,000 objects is like really, really small. In real life, in a real system, you're going to have probably like the master file table by itself is going to be 400,000, and the USN journal will have like millions of records. And so we went from 244,000 records to 8,731 records, and now we're going to export that to Excel for us to kind of review. All right. So the last thing that I like to do is maybe put it into Excel, maybe put it in Splunk or Elk, or so that you can kind of review it, make annotation, kind of build that timeline out. And so just generally what I'm doing there. But now we've basically, in a very short period of time, taken an indication. So somebody told us that there was a compromise on the web server, and we were able to determine what files are probably bad, where the web shells are, and what type of activity occurred around there. And so, for instance, we have this server manager.log. We might want to go check that out. We find out that it's actually a legitimate log file that just happened to be really busy around that time. And so we can filter out like 8,000 different records, and now we're getting closer and closer to what actually happened. Okay, so this is really cool. So we just did all of that. Now I'm going to use a technique that a guy named Ryan Benson, who works for, he just changed jobs. I don't know who he works for now, but he used Gorse, which is like a data visualization tool set. So they were using Gorse originally for like visualizing commits to GitHub. And so like seeing what users were making the most commits and how they were doing that. But he's like, hey, we could do this for USN journal activity. And then I was kind of like, well, we could also do this for forensic timelining. So I wrote a convert to Gorse commandlet, and then you could pipe that forensic timeline into Gorse and visualize what happened. And this is like, this situation, this like web server attack was very convincing inside of Gorse. So here we are. That's the master file table, meaning files that are created. As you see, there's a lot of stuff happening down here, and it's about to go even crazier. So all those files are being created over, the time period here. And so something, unless you're Amazon or somebody gigantic that has tons of web server stuff, if this is an internal web server or like a small company's web server, that's crazy. Now we start to see all these files, which are the web shells, being added right after all that crazy activity happened. So just kind of neat to be able to visualize. So we see some sort of brute force activity that ends, and then immediately we have a bunch of web shells being uploaded. So that saved us, I don't know, what, 10 minutes or so of what we just did. All right, so yeah, so no, so the visualization was made from the MFT and the USN Journal. So in that video, I already had it because I just didn't want to waste the time. So I ran get forensic timeline and then piped that into convert to Gorse, which is another commandlet that's in Power Forensics. Yeah. So I was kind of doing that to show my thought process of how I would approach the problem. And the cool thing about that is that gave me a time frame to really wrap my head around, right? Instead of just saying, hey, what's happened all time on this system, right? In real life, that's going to be crazy. You're going to have millions of things to look through. I want to say, what happened during this 24-hour window? Or maybe you don't find enough information, or you see that the information happened greater than 24 hours out, and so you start expanding that window slowly. And so that allows me to kind of zoom in. And so the convert to Gorse, I just didn't do that because I already had that time frame. But yeah, in general, you have get forensic timeline, and if you just want to shoot that out and gather all the information, you can. You don't have to do all the stuff beforehand. I just like to kind of be able to narrow in on what I'm looking at, which is where the analysis comes in. All right, so this is what I talked about today. So in general, I think PowerShell is an amazing tool for threat hunting, whether you want to do gathering information from a pull or a push methodology. So you can use WMI, WinRM, those types of tools. We also have SimSweep, PS Gumshoe, and Uproot to kind of help you out with that. And then we like to investigate with Power Forensics just because it's relatively fast. Like I said, like Incase, which is the most traditional forensic tool you could possibly imagine, parses in like 10 minutes the MFT, as to where Power Forensics will do it in probably less than 10 seconds. And it gives you all the ability. So one of the big things that drove Power Forensics was traditionally people like to use Python in forensics, which boo Python, I guess. But yeah, okay. But yeah, so they'll have like, all right, here's the tool to get a locked file from a system, right? And then here's the tool to parse the MFT. And then here's the tool that allows you to parse the prefetch. And then here's the tool that allows you to like create a timeline. And then the tool that allows you to filter the timeline. And then the tool that does the tool thing, and it does more tool stuff. And so it's like now I have to know like 50 different scripts that are written by different people and like don't conform to any standardization, as to where PowerShell, like there's a help system, there's named parameters, you could tab things out, all kinds of stuff. And so, and you could build on like things like date times, and you could do grouping objects and all kinds of stuff. And so it just makes the process a lot easier, in my opinion. So yep, so that's what I talked about. If anybody has any questions, I'd be happy to answer. Yeah. Sure. Yeah, so WMI event subscriptions, there's 5 different types, one of which is of consumers, one of which is the command line event consumer. And so that allows you to execute an arbitrary command, basically. And so in theory, you can use PowerShell as your command, and you could pass that script in as what you want to execute. Well, yeah. Good. Yeah, so there's a thread class. Yeah, you're right. Okay, so yeah, so what you would have to, yeah, it's kind of convoluted. We were talking about this yesterday, actually. But yeah, so there's a thread class. Every time a thread starts, you could then kick off a command, which would then be get injected thread, which would then check all threads, but that thread in particular for that, and then do something with it. So that, I think that might be pretty convoluted, but I think it could work in practice. So yeah. That's one of the. Yeah, well, you're creating threads. Yeah, so yeah, I guess, yeah, it could be dangerous. So yeah, heavy testing needed. Anybody else? It looks like you got another one. Yeah. Yeah, so things that we like to look at are, so it's gathering token information is one thing I kind of breezed over, but what it'll do is it'll gather process token information, so like who's the process owner, what context are they running in, have they elevated past the UAC prompt, have they, all that kind of stuff, but it also gets the thread token. And so if the thread doesn't have a unique token, it has the same token as the process. But if it does have a unique token, and say the thread is running as system with in the high context past the UAC, but the process is running as Joe Schmo user, and it's not past the UAC, then that's probably really bad. And so that would be something you could look at. Or you can take the first 100 bytes, or even go gather all of the bytes and then throw it into, like Matt wrote, PowerShell Arsenal, and it allows you to disassemble bytes into IL or assembly. So you could kind of check it out that way. Any other questions? Yep. So yeah, for power forensics in particular, yeah. So that's all built on C#, and so it's I'm going to go into this a lot on Friday and how the project is kind of organized and how it works. But ultimately, it's a C# assembly, right? So C# DLL that you could then import into PowerShell, and then it exposes like the Power Forensics namespace, which has tons of classes. And so then I have PowerShell scripts that wrap those classes and give you functions or commandlets. Yeah. So one of the key components to Power Forensics is that I don't want to rely on the Windows operating system, because if there's a bad guy there, he could inherently lie to you. And so like the MFT parsing is 100% like, we say like artisanally crafted by hand, right? So I wrote the MFT parser, the registry parser, the USN journal parser, and so we're not relying on any Windows APIs except for create file, which allows you to get access to the hard drive itself to read those bytes. So that would be the one place where you're kind of vulnerable, I suppose. Yeah. So like anybody that's doing disk acquisition, like with DD, you're using create file. So at the end of the day, everybody's vulnerable to that. So unless you're taking it offline and like pulling the disk and shipping it across the world or whatever. So yeah. Anybody else? Cool. Well, thank you for your time. I appreciate it, and thanks for coming.